Hi all, welcome back. My name is Mohini Yadav and this video is the part 2 video of our Differential Calculus video series, and in the last video, part 1 video, we were left with the derivative of power function in which we discussed the two questions. So in this video we will be discussing furthermore two questions before moving to the next rule. So suppose in this question the function of y is given as 2 divided by under root of x and you have to find the derivative. Now we know that the under root of x is equals to the x raised to power 1 by 2 because the root is nothing but just the expression of the power of 1 by 2 and it is in the division. So when we'll multiply this, the power will become negative. So that you have to remember that whenever the power is given in the denominator, so when you multiply it, the power will become the negative. So in this case, 2 divided by x raised to power 1 by 2 will become 2 multiply with x raised to power minus 1 by 2. Now this particular function is called the power function, and we already know that the derivative of power function is constant multiplied n times with the function raised to power n minus 1. So in this case it will be 2 multiplied by minus 1 by 2 multiply with x raised to power minus 1 by 2 minus 1. So this will become minus 3 by 2. 3 by 2, and in this case 2 and 2 will get cancelled. So the answer is minus 1 into x raised to power minus 3 by 2. I hope this is clear. In the next question, suppose your equation is this, that y is equals to 3 divided by x raised to power 4. So as again, in case it is divided with some power, when we multiply this, the power will become negative. So it is 3 into x raised to power minus 4. Now we have to take the derivative. So the constant is 3 into power minus 4 into x raised to power minus 4 minus 1. So it becomes minus 12 x raised to power minus 5. Okay. Now we'll jump to the next rule, which is the sum or difference rule. So this is very easy rule. As per this, the derivative of sum or difference of two functions is the sum or difference of their respective functions. So if there are, for example, two functions fx and gx, and in case we have to find the derivative of these two functions, then we'll calculate the standalone derivatives of the respective functions and then we'll just simply add them or subtract them as per the case. So for example, your function is given as this, y is equals to 4x raised to power 4 plus 5x raised to power 5, and you have to find the derivative of y with respect to x. So we'll calculate the derivative of 4x4 and separately we calculate the derivative of 5x raised to power 5, and since there is a addition, so we'll just simply add them up. So this is power function and this is also power function. So this will be 4 is to 4 x raised to power 4 minus 1. Similarly, this will be 5 into 5 x raised to power 5 minus 1. So this will become 16 x raised to power 3 plus 25 x raised to power 4. So this is your answer. Next question is this. Suppose your function is like this, where y is x cube plus 4x square minus 3 divided by x, and you have to find the derivative. So first what we'll do, we'll simply just divide every function with the x. So this is x cube by x, 4x square by x minus 3x. Oh, sorry, it was x here. Yeah. So minus 3x by x. So x will get cancelled. In this case, x will get cancelled. So there will be only x. In this case, x will cancel and now it will be 2. So this is x square plus 4x minus 3. Now this is addition and this is subtraction. So you'll calculate the differentiation of these individual functions and then you'll just simply add and subtract. So first function, derivative x square is 2x. Then the derivative of 4x is 4 and the derivative of constant is 0. So this is 2x plus 4 is your answer. Okay. So now we'll shift to the next rule. So next rule is product rule. So in this case, you have been given two differential function, that is fx and gx, and the derivative of their product, how we can calculate it. So first function as it is, derivative of second function plus second function as it is, derivative of first function. So this you have to remember. So suppose this is the question that if y is given as a function of 2, that is this is fx, this is gx, and you have to find the derivative of y with respect to x. So in this case, how will you solve it? First function as it is, differentiation of second function plus second function as it is, differentiation of first function. Now this function as it is, the differentiation of this function will be 4 into 4 x raised to power 4 minus 1 plus 4 into 3 x raised to power 3 minus 1 with this constant, it is 0. Then the next function, second function will remain as it is. The derivative of first function is 3 into 3 x raised to power 3 minus 1. Then 3 into 2 x raised to power 2 minus 1, and for constant it is 0. So when you will simplify it, then it will become this function 16x cube plus 12x square plus second function as it is 9x square plus 6x. So this is the derivative of these two functions. I hope this is clear. Now we'll jump to the next rule, and this rule is the quotient rule. So suppose there are two differential functions and the functions are given in the division format, that is fx divided by gx, and it is also that the gx function is not equals to 0. In that case, your differentiation rule says that the denominator function, that is gx as it is, derivative of the numerator function minus numerator as it is, derivative of your denominator function, divide by denominator whole square. Okay, you can also write this like this. When you have to find the derivative of numerator divided by denominator, then it is denominator square, and in the numerator side you will keep the denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator. So for example, if y is given as a function of this and you have to calculate the derivative of y with respect to x, so the rule says the denominator, it will be whole square, then denominator as it is, derivative of your whole numerator minus numerator as it is, derivative of your denominator. Okay, so this is as it is, and this is now sum or addition rule. So in this case, this will be 3x raised to power 3 minus 1 plus 4 into 2x raised to power 2 minus 1 minus 0 minus this function as it is. Derivative of this will be 2x raised to power 2 minus 1 and the constant, it is 0. Then you'll further simplify it. So this is as it is. This will become 3x square plus 8x, then minus this function, that is x cube plus 4x square minus 3 into 2x divided by x square plus 1 का whole square. So this is the way you have to solve the quotient rules. The next important rule is the chain rule. So this rule says that if y is given as a function of u, it is said that it is differentiable function of u, and u is given as a function of gx, which is also a differentiable function of x, then y, function of gx, is a differentiable function of x. Okay, so this means if y is given as a function of u and u is given as a function of x, then in case we have to find the derivative of y with respect to x, we can directly use this formula, in which we will derive the first derivative of y with respect to x, and then we'll multiply the derivative of u with respect to x. So this is dy by du into du by dx. So suppose you have been given this equation where your y is equals to u cube and u equals to this function. By applying the chain rule, first you will find the dy by du. So this is x raised to power n formula, which is n into u raised to power n minus 1. So this is 3u square. Then you will find du by dx. So this is sum or difference rule. So in this case it will be 9x square plus 5 constant, it is 0. Then dy by dx is this multiply with this. Now you just have to substitute the value of u. So this u is 3x square plus 5x plus 3. So just simply substitute this value. You will get the dy by dx. So this is very simple. You just need a hands-on experience. Then you have to see that chain rule is very helpful in finding the derivatives of quantities which are raised to powers, right? Because power rules also we can apply, but chain rule is somehow little bit more easy. But we can also apply the direct power rule also in our case. So if we apply the direct power rule, it says that if your function x raised to power n, then what you will do, you will simply move the power and you will multiply this with the function, and the function power will be subtracted with 1 into the derivative of function. So earlier we were simply using x raised to power n. So in this case is very easy. But now what is happening, for example, x square plus x cube or something else is also given along with the powers. In that case you can't use the power rule easily. In these cases you have to use this function where the function along with function is given. Okay, so this is very simple. For example, this is the equation 2x5 minus 5x cube plus 7 raised to power 28. So in this case what you can do, you will simply move 28 to the left hand side, power 28 minus 1 into derivative of this function. So this will become 28 function raised to power 27 into derivative is 10x4 minus 15x square and constant is 0. I hope this video is clear to you and all the rules which we have discussed so far. In case of any doubts, please write to me, and please subscribe to my channel. It is very important for me. Thank you so much for all the support. See you for the next video. Bye bye. Till then, please take care.